In the last video, we looked at the thread class and two different ways to create a thread and to run them concurrently with the main thread. In this video, I'll focus on methods to both manipulate and communicate with running threads. There's one method you've already seen before, and that's the sleep method, a static method on thread. This method allows you to pause the execution of a thread for a specified amount of time. It temporarily suspends the execution of the current thread. You can do this in the main thread or in any concurrent threads you create. I've created a new project called Running Threads with the usual main method. I'll first print a message that the main thread is running. Next, I'll simply call thread.sleep here, passing 1000 milliseconds, which we know is 1 second. IntelliJ is giving me an error, and if I hover over that, you'll see that I'm getting an unhandled exception, an interrupted exception. By now, you know this is a checked exception and that I have to either handle this or include it in a throws clause of the method. I don't want to add this exception to my method signature, so I'll pick more actions and I'll select try catch. Now, notice that the catch block is throwing a runtime exception. This is one way to handle the situation, and I don't have any compiler errors. I'll instead change that code to just print the stack trace. I'll output a statement before this thread sleeps. I'll print that the main thread is paused for 1 second. I'll also print a message that the main thread will continue here. Running this code, you can see the main thread running, then the code pauses for 1 second and finishes by printing main thread will continue here. Now, to create a concurrent thread, I'll create a new instance of thread and pass it a runnable Lambda expression. I can define this directly in the constructor all in one statement. I'll create a new thread and start a new multi-line Lambda expression here. I'll start by getting the thread name. Because this code will execute in a new thread, it will return that thread's name. I'll print a message that this task should take 10 dots to run. Inside this Lambda's code block, I want to print a dot every half second for 10 iterations. To start with, I'll set up a for loop to loop 10 times. I'll print a dot in each iteration. I need a try block because I'll be using thread.sleep. I'll have the thread sleep for half a second. Here, I wanted to catch the interrupted exception, and I'll print a message that prints whoops, the thread was interrupted. I'll include the thread name in my message. Finally, I'll exit the loop if this happened. After this for loop, I'll print that the thread completed its work successfully. Finally, I'll print that I'm kicking off this concurrent thread, and I'll include the thread name by calling getName on the thread variable. Lastly, I'll start the new thread. Running this code, I see that my new thread's name is thread0 and it's starting. Notice that the method about the main thread continuing was printed before any dots were printed. I get the message that thread0 should print 10 dots, then I start seeing the 10 dots. Finally, after the dots are printed, I get the message that thread0 completed. Now that I've got a running thread that catches an interruption, I'm going to actually interrupt this thread from the main thread. First, I wanted to give it a little time to run, so I'll have the main thread sleep for 2 seconds. I'll print an error message if the main thread is interrupted. I'll interrupt the new thread by calling the interrupt method on the thread variable. Running this code, the output starts the same until I get to 4 dots, which if you think about it, is 2 seconds. Then I get the message that thread0 was interrupted. That's how you'd manually interrupt a running thread from the code that started the thread. You can use the thread variable, as our main method does here, and call interrupt on that variable. You can imagine that if your asynchronous thread was downloading a file to the user's computer as one example, and the user decided to cancel it for some reason, this interrupt would stop the download and close any resources as necessary. Let's change this code a little bit and only interrupt the thread if it's taking longer than 3 seconds. I'll remove all the code I have here after the thread.start method. Before I add code though, I want to change the code in my concurrent thread. In this case, I'll just add some print statements that will print the state of the running thread. I'll print the current thread state after each sleep method using ASMI placement indicator. I'll also print the state when the interrupted exception is thrown. This time I'll use a 1, not a, so I know this message is coming from this catch clause. Next, I'll get the current time in milliseconds elapsed from the epoch time. I use system.currentTimeMillis for this. I'll use this to determine how much time has elapsed. Now, I'll hang out in a while loop as long as the isAlive method returns true on my asynchronous thread. I'll print that I'm waiting for the thread to complete. I need a try because I'm going to use thread.sleep. I'll sleep for 1 second. I'll print the thread state here too using BSMI indicator in this thread. I'll catch the interrupted exception and print the error's stack trace. Next, I'll add an if statement after the thread.sleep method. If the current milliseconds minus the number in my now variable results in a total elapsed time that's greater than 2 seconds, I'll interrupt the thread. After this while loop, I'll print data about my thread variable now. I'll print the state one more time here using CSMI placement indicator. I'll run this. Notice, when the thread starts, the status of the thread within its own run method is runnable. This is prefixed by the A. But look at the status of B, where we ask for the thread status outside of the thread. The status is more often than not timed waiting. We see these both printed after each half a second. Next, you can see A1 is printed, which is in the interrupted exception block, and the status is still runnable. But by the time B statement is called, the state of this thread is terminated, as it is when this while loop exits or at C there. These different states are values on an enum that's declared on the thread class and called thread.state. A thread is in the new state before we execute the start method on it. An executing thread will be in the runnable state as long as it's not waiting for something. A waiting thread could be blocked, meaning Java recognized a blocking condition. I'll be covering these a bit later. A thread could be waiting on another thread, which can occur if you join this thread to another. You could be waiting on some timed event, in which case you'll see time waiting, for example, for a thread.sleep to end or some other timeout condition. Finally, a thread is terminated when it successfully completes or is interrupted or its run execution is stopped by some other means. Okay, so now we know how to get thread states, but you'll notice there's not an interrupted state. That's because there are methods to check if a thread was interrupted on thread. Before I look into this, I want to switch gears for just a minute to talk about the join method on thread. This method lets you create task dependencies. Let's imagine that our current thread is downloading an installation package. When it completes, we want to start a separate installation thread, but only if the download actually completed. I'll create the install thread here next. Before I do that, I'll just clean up my code and remove all the statements that output the thread states. I'll clean up the 2 in my initial thread's lambda expression, first in the try block, then in the catch block. I'll then remove the statement in my main thread's while loop after the thread.sleep statement. Lastly, I'll remove the statement at the end of the main method. Now, I'll create a new thread and put this code immediately after the first thread variable. This time, I'll call this thread variable install thread. I'll start with a new instance of thread and pass it a lambda. I'll be using thread.sleep, so I need a try catch. I'll loop 3 times, sleeping 250 milliseconds each time. Then I'll print that an installation step is completed. I'll catch the interrupted exception and just print the info. Here, I'll pass a second argument, which lets me set up my own name for the thread, so I'm going to call this thread the install thread. Now, I definitely don't want this thread to run until the first has completed successfully. I'll call thread.join, which joins this thread to the current thread, which in this case is the main thread. This means the main thread will wait here until this thread completes. This code doesn't compile without a try-catch block, so I'll add that. After this thread completes, I'll check if the thread was interrupted using the isInterrupted method on the thread variable. If it wasn't interrupted, I'll kick off the install thread. Otherwise, I'll print that the previous thread was interrupted, and I'll say that the install thread can't run, and I'll use that thread's name here. Remember, this is the name I passed to the constructor of this thread. If I run this code as it is, the while loop I have here, this one, where I check thread.isAlive, is going to basically negate what the join method does. I mean it's going to wait for 2 seconds, then interrupt the first thread, so that by the time I do the join, there won't be a thread running to join. I'll comment this code out for a moment. Okay, so now I'll run this. I'll see the 10 dots printed and then the message that thread 0 completed. Only after this will I see the installation steps in the install thread be executed. This join method allowed my main thread to wait here until that other concurrent task completed and before I proceeded with my dependent task. For good measure now, let's create a third thread that will be responsible for interrupting the first thread if it takes longer than 3 seconds. I'll uncomment out the code I just commented out. I'll wrap this code with a thread instance and make it part of the Lambda expression of this thread. I'll call this thread thread monitor. I'm going to remove the system.out.println statement in this code that says waiting for thread to complete. I want to start this thread at the same time as my original first thread. First, I'll just cut the statement and the thread dot start above this. I'll paste it after this thread monitor declaration. Okay, I'll run this. And oops, that didn't work because I forgot to start thread monitor. Directly after the thread.start, I'll execute thread monitor's start method. I'll run this. I get about 4 or 5 dots printed before thread 0 is interrupted by the concurrent thread monitor thread. But something has gone wrong here because the installation code ran when it shouldn't have. The test on thread using the isInterrupted method failed. What's happened here? If you do a bit of research, you'll find that Java recommends that any method that catches an interrupt exception and is not prepared to deal with it immediately should reassert the exception. They recommend reasserting it rather than rethrowing it because sometimes you can't rethrow it. The thread has to reinterrupt itself, or in other words, it has to call interrupt on itself. Scrolling back up to my original thread method and looking at the interrupted exception block there, I need to reassert this interruption in this code. I'll call interrupt on the current thread. I'll run this code again. I can see that the thread was interrupted, and this time my code runs correctly because now the interrupted method returns the correct result that this thread was interrupted. That's a little confusing, I know, but just remember it's a good idea to add this bit of code, and this should fix any kind of weirdness around this status being reset during the thread process. For good measure, I'm going to change my thread monitor method from 2000 milliseconds to 8000 milliseconds. Running this again, my thread should actually print its 10 dots successfully. Now you can see that thread 0 completed and the installation steps were executed. In this video, we used the interrupt method to interrupt a long-running thread. I also demonstrated how to use join to make a dependent task, waiting until a previous asynchronous task finishes before any thread will be launched. I'll have an opportunity to show this to you in upcoming videos. In the next video, I want to give you a little thread challenge. After that, I'll be talking about some problems that can occur if your concurrent threads start working with objects in your processor's heap memory. I'll see you in that next video.